All right, these are the notes for 3-4. This is the derivative of the inverse trig functions. And this is not on the AP test a whole lot, but it is on there sometimes. One or two questions the most. Also, I want to make sure you realize we're having a quiz 3334 on next Friday on Canvas. We'll not be Zooming that last day before break, but you'll have a quiz to take on Canvas. And it'll be timed. So over here on the right, these are the basic inverse derivatives of basic inverse trig functions right here. But the only time these work is when you just have a regular old x. Over here is when you got something besides a regular old x. So not only do you do 1 over 1 minus the angle, which is the same here, 1 over 1 minus the angle, then you multiply it. You multiply it by the derivative of whatever this u is. Now it's this u, not u squared, but the derivative of this u. So it's that u prime here. So you don't have 2u, you just do the derivative of this. And again, I want you to notice when you do the derivative of any of these c's, they all have a negative. All of these have a positive. So we're going to let y equal the arc sine, and we're going to find the derivative of y with respect to x over here without using these functions. So in other words, we're going to find this. And just so you know, something that you should know is that arc sine of x is the exact same as the inverse sine of x. Those arc and inverse symbol mean the same. So make sure you make a note of that, that arc and inverse are the same. So we write these as arc. Sometimes they might write it as the inverse. So the first thing you would do on a problem like this one, where we start with this, is we're going to take the sine of both sides. Because when I take the sine and inverse sine, or arc sine of an angle, that sine and inverse sine cancel each other out, so I get the sine of y equals x. And then I'm going to do the derivative of this thing with respect to x, and the derivative of this thing with respect to x. So when you do the derivative of sine, okay, you're going to get cosine. Keep the angle the same because this is chain rule. And then times the derivative, which is dy dx, because we are doing an implicit differentiation with respect to x, but we're doing y, so we got to put our dy dx in there. And then when I do the derivative of x with respect to x, that's going to be 1. Just like it always has been. So what that means is dy dx is going to equal 1 over the cosine of y. So something you need to know here is when I do an inverse problem, the x becomes y and the y becomes x. So what this means is when we have this triangle we're dealing with over here in this quadrant, and maybe I should have just drawn a triangle instead of the whole thing. This distance right here is the 1. This distance is the x, and from Pythagorean theorem, this thing down here is 1 minus x squared, and that 1 minus x squared comes from x squared plus question mark squared is going to equal 1 squared. So this is the question mark. So you subtract x squared over, and you get question mark squared equals 1 minus x squared when you subtract this over. And then when you square root it, the question mark is positive or negative square root of 1 minus x squared. But this value is positive going right from the origin. That's why it's this. And so we are talking about this angle right here. So cosine. The cosine of y is adjacent, which is this thing, over hypotenuse, which is 1, which is y. This bottom part is this over 1, which is just 1 minus x squared. So if you look at this up here, right here is, this is how we get to that answer. You can do all of them this way, but we're not going to. So the big deal is we want to try to memorize our equations. So we're going to do this problem over here. And it says do the long method. That long method we're doing like I did right here, but I don't want to do the long method. So I'm going to, oh, I guess he gave you the long method here, looks like. So he did the long method. So we're going to do the short method. So I'm going to use this formula up here. I'm going to move it up a little bit so you can see it. So when I do the derivative of this, it is going to be on the bottom, you're going to have the square root of 1 minus, now u is this 2x. So since it says u squared, I've got a square 2x, which gives me 4x squared. And then remember on top is u prime. So u is 2x and the derivative of 2x is 2. So there is the fast way to get this answer without going through what we just did up here. I'm going to do this one the fast way also. We're doing arctan. So arctan, and again, I'm using this one, is going to be, now there's no square root on this one. It's 1 plus u squared. And again, the u is at 3x. So when I square 3x, I get 9x squared. And then on the top is the derivative of 3x, which is 3. So this is the answer for the inverse derivative of tangent. The next page is we're going to do a couple more of these. So I'm doing the inverse tangent again. Now we're going to want to think of this as being x to the 1/2 power when we do the derivative of it here in a minute. So this is going to equal, and on the bottom it's 1 plus, and u is the square root of x, or x to the half. And if you square that, you're going to get just regular old x. And then we want the derivative of this on the top. So this is 1/2 x to the negative 1/2. And then you can move this 2. Well, we can rewrite that as 1 over 2 radical x all over 1 plus x. And then we can flip this bottom over to multiply. And when we do, we would get 2 radical x times 1 plus x. So that would be the answer to this problem. And then we're going to do the inverse of secant. Now again, I want you to realize u is this part, okay? But we have a square out here now. Y'all see that square? So this one right here is going to be a chain rule problem. So we have to do the chain rule of this one. So when we do this chain rule deal here, we're going to start with this outside part, that 2. And we're going to put the 2 in the front, and then we got to keep the inside the same. So this will be the secant inverse. And we got to leave the angle the same with 2x. And then we lower that power by 1, which you can put a 1 there. You don't have to. And then we got to go inside here and do the inverse of this part. I'm sorry, the derivative of this part. So the derivative of secant is going to be 1. Oops, this is times because it's chain rule, my bad. So we're going to have times, and the derivative of secant is going to be the absolute value of x, or u, excuse me. Again, this is the u part here, so it is 1 over the absolute value of that, or just actually just the absolute value. So we're going to put e to the 2x in here. And by the way, we would not need these absolute values because e to any power is a positive anyway. But I'm just going to leave them in the absolute value symbol. And over here, we're going to have this u squared. So we're going to square that. So that's going to be, and it's in a radical. So that's e to the 4x. Okay, and then we got a minus 1 in with that. And on the top part, we got u prime. So I got to do the derivative of this. So I hope you remember that the derivative of b to any power is e to the power times the derivative of that power, which gives me a 2 here. Okay, so that would be the derivative of secant to this. And then the last step is we haven't done the derivative of the power yet. So let's see, we got to simplify all this stuff. So we're going to take this 2 times this 2, and that's going to give us a 4. And we got this part right here, which is the inverse secant of e to the 2x. should. We also have, I hope we can see that this e to the 2x is going to reduce with that e to the 2x. So that's going to leave us on the bottom with the square root of e to the 4x and then a minus 1 in that radical. Now that's pretty hard stuff. Okay, that's hard stuff. Now, sometimes we'd have to worry about this being a positive or negative value here because of whatever's in here. But again, when you graph any y equals e to the x, just a little review time here. I hope we know if we get 0, it goes through 1. So this graph, the horizontal asymptote is the x-axis, and I missed the dot, and it goes up like that. That is e to the x. So this never equals 0. So this value here is always positive. So I didn't even need the absolute value there. So this is the answer to that problem. That's pretty hard stuff. And now we're going to do this was the last part of 3.3. I was going to do it again. I don't need to do that. So I guess we're done with those notes. So I will see you guys next time.